The brightest and hottest planet in our solar system is Venus, which we also call the morning star and the evening star on Earth. Venus is the brightest object in our night sky after the moon. It is quite similar to our Earth in many ways. It is also called Earth's twin sister. In the beginning, people believed that maybe Venus also had forests, oceans, and an atmosphere similar to Earth. But when initial space missions studied it, it was found that there was nothing like what scientists had imagined. In fact, it is a huge planet filled with volcanoes and hot gases, which is called the hell of the solar system and is the hottest planet in our solar system. Venus's atmosphere is filled with carbon dioxide and it rains sulfuric acid here. The surface temperature is extremely high, around 490 degrees Celsius. The atmospheric pressure here is about 90 times higher than that of Earth, which makes it extremely difficult for life to exist here. But scientists also believe that due to some mystery here, everything is upside down today. This mystery of Venus is what draws us in, which is why we've launched so many missions to it throughout history. So friends, in today's mission's history, we will learn about 10 such mysteries of Venus that even scientists are puzzled by. Number 1. Secret of Venus. By the Institute of Astrophysica, Venus. The study conducted here is the most detailed and accurate study so far which has been done on any Earth-based atmospheric pressure, allowing us to measure up to about 1,500 km in altitude, which is why it flows. In Venus's middle atmosphere, wind speeds reach around 700 km per hour, much higher than any Earth mission has experienced. The average speed here is about 360 km per hour. Because of this, we are quite missions have helped us understand the history of Venus even better. And these will also help us a lot with future missions. Number 2. Did Venus ever host life? As I mentioned a little while ago, scientists believe that Venus had an atmosphere similar to our Earth millions of years ago, so this means that life might have existed on Venus as well. For this, it is necessary to study the geology and history of Venus in detail. Dr. Giada, the principal investigator at NASA Goddard Space Flight Center, believes that if Venus was truly habitable in its past, then we might be able to find traces of life from that time there. And if that happens, then Venus will become the second habitable planet in our solar system after Earth. Number 3. How did Venus and Earth come to be so different? The shape and density of Earth and Venus are almost the same, but that's only until we talk about the atmosphere. Because Venus's atmosphere is 90 times thicker than Earth's atmosphere, or because of the high concentration of sulfuric acid in the clouds, the surface temperature there is 900 degrees Fahrenheit. For scientists, the surprising thing is that these two planets, which at the beginning of the solar system, by studying Venus, we can find out how planets actually evolve. And maybe by studying this in the solar system, we might find life somewhere else. Scientists also suggest that because of the runaway greenhouse effect on Venus, its environment was completely destroyed. It is believed that doing this becomes even more important for us so that we can better understand the history and future of our own planet, so that we can also save life here and Earth doesn't end up like Venus. Number 4. How did Venus number 4? According to this, both planets were born from the same nebula and the same composition, but understanding their formation precisely is a challenge for scientists. The asteroids and comets that brought water to our Earth, maybe those same asteroids also brought water back then. It was very difficult for vast seas and oceans to form there, but still, the same question keeps coming back to the same point. Despite having so many similarities, why are the atmospheres of Venus and Earth so different? And why is the rotation of both of them completely different as well? By studying the magnetosphere, we can learn about the origin and development of this planet. And we will also find out how important a role water plays in sustaining life on a planet. Number 5. What is atmospheric pressure? If we talk about the atmospheric pressure of Venus, it is still very mysterious to us. We still know very little about it. Venus's atmosphere is very dense. It's mostly made up of carbon dioxide. Its atmospheric composition is about 95% carbon dioxide. And the remaining 3.5% is nitrogen. If we talk about the temperature of Venus, most of its clouds are filled with sulfur. Because of this, it keeps raining something like sulfuric acid here. This planet is surrounded by a thick layer of sulfuric acid, which makes it very difficult to see the surface of this planet. Because of this, the clouds here absorb 90% of the sunlight coming from the sun. Number 6. How were the rocks of Venus formed? The rocks of Venus were last touched by the Soviet mission Vega 2 in 1985 when it successfully landed on the surface of Venus. Venus's rocks have remained a mystery to us ever since. Most of the surface of Venus is made up of material produced from lava released by volcanoes, but there are also some highlands here where the composition of the rocks is different, which is formed by the interaction of water and rocks. To study this region in detail, NASA is launching the Da Vinci mission, which will study the noble gases and atmosphere here in a better way. This could give us important information about Venus's rocks in the future. NASA's exploration of Venus has revealed many secrets about this place, but the biggest mystery among all of these is how much water was actually present on Venus. To find this out, we need to study Venus's atmosphere and its rocks in even greater detail. This will help us find traces showing whether water exists in Venus's crust, and this can also help us find out where all the water on Venus actually disappeared. We may get answers to all these questions through NASA's future missions like Da Vinci and Veritas, which will help us understand the evolution of Venus in a better way. Number 8. Venus surface activity. Scientists are studying the surface activity happening on Venus, such as the movement of tectonic plates and volcanic eruptions. Although understanding these is still very difficult, with the help of probes like Da Vinci and Veritas, it will become a bit easier to understand them. This will help us understand the activities happening on Venus in a better way. The evidence of tectonic activity on Venus is its volcanoes, valleys, and mountains. But the tectonic movement happening on Venus is completely different from the movement happening here. On Earth, the movements of tectonic plates are global, which tells us about the breaking and formation of continents, but nothing like this happens on Venus. After all, it's still a bit difficult for us to find out what kind of mountains are seen on Venus because it's very hard to see the surface of Venus from space as it is surrounded by clouds of sulfur. However, we do have some pictures of Venus's surface which were taken by landers from previous missions. But we can only get high-resolution images from missions like Da Vinci because their technology and cameras are much more advanced, and it will be landed in a completely new region. Scientists are also also eagerly waiting for this mission to study the surface. Number 10. Are there Venus-like planets beyond our solar system? Could there be planets like Venus outside our solar system, which we call exoplanets? Scientists are trying to discover planets beyond our solar system with the help of new technology like the James Webb Space Telescope. All the knowledge we currently have about Venus will help us understand other planets similar to Venus. The James Webb Space Telescope can help us a lot with this. Scientists have studied the planets present in the TRAPPIST star system, which is considered the most popular and one of the biggest contenders for potentially hosting extraterrestrial life. In fact, it is located about 49.5 light years away from Earth. This star system is similar to our solar system. It is a large stellar system. It contains a total of 7 planets which are orbiting the red dwarf star TRAPPIST-1. In fact, some of these 7 planets are present in the Goldilocks zone, or you could say the habitable zone of this star, which greatly increases the chances of life developing here. A recent research report has made many revelations related to the existence of life here, which have even surprised scientists themselves. Well, stay tuned to understand in detail the research conducted on the inner planets of the TRAPPIST star system. Watch this video till the end, friends. The publishers of this report are quite frank. That's why the very first line written at the beginning of this report has broken the hearts of many optimistic people. The authors of this report write that there is a strong possibility that none of these planets have any atmosphere. Also, the conditions present here may not meet our criteria for supporting life. But apart from all this, there is still a lot here that will surprise us. So let's turn the first page and move forward in this report. Well, these planets orbit their parent star TRAPPIST-1 so closely that their own temperature remains above 500 Kelvin, which is roughly around 230 degrees Celsius. This temperature is so high that you could even bake a pizza on it if you wanted to. Apart from that, even before the James Webb Space Telescope, studies have been conducted on these 7 exoplanets with the help of the Hubble and Spitzer space telescopes, and even then, there was no evidence found of the presence of an atmosphere on these planets. But this time, when they were observed with Webb's infrared capabilities, the study was conducted with much greater precision than before. The mid-infrared sensors present in the Webb telescope were a very important element of this study, because it is thanks to this that it is possible to analyze even the tiniest components of the atmosphere. Compared to its predecessor, the Webb has the capability to observe microparticles with 400 times more clarity, which enables it to see the far reaches of the cosmos. In this context, scientist Thomas Graney, who is working on this research assignment, commented on the performance of the Webb. In the initial phase, he tried to find traces of atmosphere on these planets with the help of the telescope's mid-infrared data. In this context, he studied how these planets affected the light, but unfortunately, he did not find any evidence related to the atmosphere here. And the biggest reason for this was that these planets were a bit too close to their parent star. Now look, we all know that temperature is a foremost factor for the presence of an atmosphere on any planet. Now, when these planets are so close to the star, it's obvious that they will receive a lot of radiation there. As a result, there will be a sudden rise in the planet's temperature, which will never allow a high-pressure atmosphere to develop there. Something similar was the case with the planets orbiting TRAPPIST-1. Due to extremely short distances and a lot of heat, there was no atmosphere present here at all. However, when they couldn't find anything through this method, they tried another technique. Under this, instead of photo observation, they adopted another approach to check the temperature of that planet. Thomas Graney and his team, who were working on this assignment, again started their investigation using the MIRI, that is, the mid-infrared instrument of the James Webb Space Telescope. In this process, they created a thermal signature of this planet, which contained details of the mid to long wavelength radiation being emitted from it. This thermal study explains the emissions of this planet. It is mentioned in the research paper that they detected the second eclipse of this planet, during which the planet was passing in front of its host star. They noticed the temperature of the day side of this planet and based their entire study on that. Further researchers state that when this planet was passing behind its star, James Webb detected a blended light which included the light coming from the day side of the planet as well as the light from the star itself. Because of this, the system appeared much brighter. However, after a while, as the planet started moving to the backside of the star, the brightness began to decrease. And by calculating this brightness difference, scientists were able to determine the absolute brightness of this planet in particular, and based on this calculation, they also found out the temperature of this planet. The team working on the Webb data has also prepared a presentation of this comparative study. In it, we can clearly see how the exact temperature on the TRAPPIST-1b planet was derived, which has been measured to be around 500 Kelvin, or in other words, about 250 degrees Celsius. This kind of observation has proven to be a milestone in the field of astronomy, because with this, not only was the exact temperature of a distant world discovered, but a new milestone was also set for our observation instruments and scientific competence. The team of NASA scientists working on this project said that compared to the 1,000 times brighter glow of the TRAPPIST-1 star, the brightness of the planets orbiting it was like that of a dimmed lamp, and overall, this brightness difference was 99.9. In such a situation, finding that 0.1 brightness difference was a challenging yet amazing task. Taylor Bell, who is a postdoctoral researcher at the Bay Area Environmental Research Institute, when he analyzed this data, he said the main thing in this entire research assignment was not detecting an almost negligible brightness change. Rather, it was also about completing his research while taking into account the complicated orbits of this star system. He said that our biggest fear was missing the eclipse of this planet. Now, because the 7 planets present in this star system do not follow a perfectly aligned and clocked orbit just like our solar system, that's why completing the observation while avoiding interference from the other planets' flybys was also a big deal, which the scientists successfully accomplished. Anyway, leaving aside these technicalities, if we talk about the results of this study, this new revelation has also created many mysteries. Despite not finding any traces of atmosphere on TRAPPIST-1b using the first method, scientists are still looking at it with hope because there are still many revelations related to the planet's thermal emission yet to be discovered. Still, there is a group of scientists here who have completely lost hope regarding this exoplanet. According to them, the surface conditions there are so harsh that life could never exist there. But at the same time, some volcanic researchers, out of their curiosity, are planning to conduct more research in this star system, thinking that maybe we might find some traces related to extraterrestrial life on the outer planets of TRAPPIST-1, because due to the greater distances, most probably, the temperature there is quite low and there might also be ideal conditions for life to take root. By the way, today we know Venus as a toxic planet where it rains sulfuric acid and the heat is so intense that even metal can melt. Today, science says that Venus has no moons. Even so, there was a time when great astronomers made completely opposite claims. So, what is the truth? Where did those claims come from? And if those claims were true, then where is that moon today? The truth behind Venus's brightness. It's the second planet in our solar system. Its distance from the Sun is about 108 million kilometers. Its size is so similar to Earth's that it's sometimes called our twin. Its diameter is 12,104 kilometers, which is just a little less than Earth's 12,742 kilometers. But this similarity is limited only to their size. Venus's atmosphere is made up of about 96% carbon dioxide, and its thick clouds contain droplets of sulfuric acid. The clouds formed on Venus reflect sunlight so much that Venus becomes the brightest object in the night sky after the moon. Beneath this brightness is a dangerous, mysterious world where heat is so intense that metals like lead would melt in minutes. Its atmospheric pressure is 92 times greater than that of Earth. That means if a person were to accidentally stand on the surface of Venus, they would be crushed instantly. Some scientists believe that there is still volcanic activity on Venus today. The rotation of Venus is also unique in itself. It rotates in retrograde motion, meaning it spins in the opposite direction. Here, the sun rises in the west and sets in the east, which is completely opposite to the other planets. But the rotation of Venus is so slow that it takes Venus 243 days to complete one rotation on its axis. But its orbital period around the Sun is only 225 days, which means a day here is even longer than a year on Venus. All these features already make Venus a mysterious planet, but the question of its moons makes Venus even more mysterious. Today we say that Venus has no moons, but this hasn't always been considered true. And the first clue of this story comes to us from the 17th century. The first claim comes from Cassini's notes. In the year 1672, in a small town in Italy, Giovanni Domenico Cassini was exploring the sky with his telescope. Cassini was one of the greatest astronomers of his time. He observed Saturn's rings in great detail. He was the one who discovered its four moons, Iapetus, Rhea, Tethys, and Dione. At that time, it was completely beyond their understanding. Cassini wrote in his notes that there was a small object near Venus, dimmer, but it was revolving with the planet. He declared it to be the moon of Venus. At that time, telescope technology was still in its early stages. Refracting telescopes were used, which had limited lens quality, but still Cassini had complete faith in his observations. According to him, this object was at a short distance from Venus, maybe a few thousand kilometers, and it was less bright than the planet. This claim was no small matter. At that time, every new discovery in astronomy was like a revolution, but Cassini was not alone. After this, in the next few decades, more people saw it, and for many nights they observed it. Then, in the 18th century, Germany's John Henrik Lambert deepened the mystery even further. Lambert not only observed this moon but also tried to calculate its orbit. According to him, this moon was orbiting Venus at a certain distance and its orbital period could be a few days. All these claims left the astronomers of that time puzzled. Some believed it to be true. Questions started arising. If this was a moon, then why couldn't everyone see it? And if it was true, then where is it today? So, the next step of this mystery takes us towards science. The reality of Venus's moons. Technology changed with time. In the 20th century, spacecraft replaced the telescopes of the 17th and 18th centuries. Efforts to understand Venus intensified. The Soviet Union started the Venera program in the 1960s. From Venera 1 to Venera 13, all these probes reached the surface of Venus and sent us its pictures. In 1970, Venera 7 was the first spacecraft to land on Venus and transmit data. Magellan later used radar mapping to scan Venus's entire surface and sent back the data. After this, NASA also launched the Magellan mission in 1990. Magellan scanned the entire surface of Venus using radar mapping. Its magnetic field is very weak. Perhaps due to its slow rotation, the greenhouse effect in its atmosphere is so strong that it doesn't let the heat escape. But one thing that these missions made clear was that Venus does not have any moons, neither a small satellite nor a large moon. So there were issues like small satellites and spherical aberration. Venus's brightness may have caused chromatic aberration and spherical reflection in telescopes when viewing a star or planet, making it appear like a moon. The second theory that came up was that maybe it was an asteroid or a comet passing near Venus at that time, and by mistake it was thought to be a moon, creating such an illusion. But maybe even with all these answers, not every question was being solved. If it was an illusion, then how did different astronomers at different times experience the same illusion? And if it was a permanent object, then why haven't we found any record or trace of it till today? This question was pointing towards a new theory. Did Venus really have a moon that disappeared over time? Famous as the morning star and evening star, Venus hides behind its beauty a world that is even worse than hell. Extreme temperatures that don't let anything survive here for more than a few seconds, and pressure so intense that it has the power to crush anything. But the question is, why is Venus so different after all? A planet that's called Earth's twin? Why did it become a hellish world spewing fire? Over the years, several missions and the efforts of NASA and other space agencies have taken us to the untold stories of this planet. Its atmosphere, geology, and history, everything about it hides many secrets within. Today, we will journey into the mysterious world of Venus, where we will try to understand the mysteries hidden within it through space exploration plans. From the first flybys and landings to future space exploration plans, can we learn something about our own planet's past? Is this evolution, or is it just a warning? For us, for our future. Let's start decoding this unsolved puzzle of Venus, harsh environment of Venus. Venus is one of the first 4 rocky planets of our solar system, which, when seen from above, looks just like any other normal planet. But as they say, the devil lies in the details, and the case of Venus is just like that. Its sulfuric environment is completely different from any other planet in our solar system. Its thick atmosphere is mostly made up of carbon dioxide, and these clouds of sulfuric acid reflect sunlight back into space, which leaves Venus shrouded in darkness. Because of this, all the radiation and heat coming from the sun gets trapped here, making it the hottest planet in the solar system. This is also surprising because Mercury is much closer to the sun, but still, Venus is much hotter than it. NASA's early missions, like the Mariner flybys of the 1960s and 1970s, provided us with the first detailed map of Venus's atmosphere. These missions revealed that about 50 to 70 kilometers above Venus's surface, there is a layer made of droplets of sulfuric acid. Beneath these clouds, the atmosphere is mainly carbon dioxide with a thick layer of sulfuric acid cloud droplets. Below these clouds, the atmosphere is mostly made of carbon dioxide with traces of nitrogen and other gases present. Besides this, Venus takes 243 Earth days to complete one rotation. But its atmosphere is much faster in this regard. It completes a full rotation in just 4 days. Because of this phenomenon, extremely strong winds are generated on Venus, which can reach up to about 360 kilometers per hour, and this contributes greatly to Venus's extreme weather patterns. Another important discovery was made in 2007 by NASA's Cassini spacecraft, which was heading towards Saturn. It detected radio waves coming from lightning storms on Venus. This was surprising because we usually associate lightning with water clouds, not with sulfuric acid clouds. This lightning was an indication that Venus's atmosphere is much more dynamic and complex than we thought. In 1978, NASA's Pioneer Venus mission deployed 4 probes into Venus's atmosphere, which brought back valuable data about the structure and composition of its atmosphere. These probes discovered a thick layer of something like fog or haze and clouds on Venus, with droplets extending down to about 30 kilometers above the surface, where the temperature rises above an enormous 460 degrees Celsius and the pressure becomes equal to going 900 meters deep in Earth's ocean. Despite these harsh conditions, Venus has provided many unique insights about atmospheric processes and planetary evolution. By studying Venus, scientists want to understand how greenhouse gases impact the climate of a planet. this could be a better tool to understand Earth's climate change. Because of Venus's dense atmosphere, it is very difficult to see through it to the surface. But despite this, NASA and other space agencies have succeeded in looking beyond these clouds of Venus and gathering information about its surface. The biggest finding in this is that Venus is a planet that is driven by volcanic activity. Radar images from missions like NASA's Magellan Orbiter, which mapped Venus between 1990 and 1994, they revealed a surface of Venus that was filled with volcanoes, vast lava plains, and rift valleys. Magellan's radar mapping showed that about 85% of Venus's surface is covered with volcanic rock. This indicates that volcanic activity has played a major role in shaping the landscape of this planet. There are thousands of small and large volcanoes present on the surface, some of which are small shield volcanoes and some are massive volcanic structures. For example, Mount Mons, which rises about 8 kilometers above the surrounding plain. Another surprising discovery of the Magellan mission was that it found evidence of recent volcanic activity. Some volcanic features present on it, such as lava, lava flows, and domes, appear geologically young. This indicates that Venus might still be volcanically active today. This has been further supported by recent observations from the European Space Agency's Venus Express mission, which orbited Venus from 2006 to 2014. This mission detected certain changes in surface brightness and infrared emissions, which could be indications of active volcanism. There are also large rift valleys present on the surface of Venus, such as Devana Chasma. It stretches across the planet in a large arc for about 4,000 kilometers. These rift valleys appear to have formed due to tectonic activity where the planet's crust is pulled apart by internal forces. Apart from volcanic features, large circular structures have also been observed on Venus's surface, which are called coronae. These features form when hot material from the planet's interior rises toward the surface, fracturing even its crust. Coronae are often associated with volcanic activity, and lava flows have also been observed around some of them. This indicates that it could possibly be a site of active volcanism. At many places on the surface of Venus, we also found impact craters. On our Earth, the traces of impact craters are quickly erased due to erosion and tectonic activity. But on Venus, due to the thick atmosphere and the absence of water, these craters are well preserved. But here, the distribution of craters is very unusual. There are very few small craters here. This pattern suggests that the surface of Venus is probably quite young, which could be around 300 to 600 million years old. It is also possible that in the planet's past, a global resurfacing event occurred which erased the old craters and covered the surface with fresh volcanic material. This resurfacing must have happened due to the volcanic activity going on throughout the entire planet. This was triggered by the buildup of heat inside Venus because Venus does not have tectonic plates. Because of this, the heat could not easily escape through the crust, which is why we see periodic and intense volcanism on this planet. And during this time, a large amount of carbon dioxide and sulfur dioxide must have been released into its atmosphere, which would have made the planet's extreme greenhouse effect even more intense. History of ancient oceans Venus and Earth are often called sister planets because of their similar size, mass, and composition. But both of these planets have chosen very different paths on the evolutionary journey. Whereas Earth's climate is suitable for life and there is no shortage of liquid water here, on the other hand, Venus has become a dry, barren, and desolate world. The question arises, how did these two planets, which probably started with similar conditions, end up becoming so different? One theory suggests that Venus also once had oceans of liquid water on its surface, just like early Earth. Billions of years ago, when our sun was much smaller and less bright, Venus's climate was probably much better at that time for any kind of life. In such conditions, it's possible that Venus had a stable liquid water ocean which could have created a suitable environment for life. But as the sun grew and became brighter, Venus's surface temperature also started to rise. Due to the lack of plate tectonics, which regulate carbon dioxide levels, and the absence of a strong magnetic field which protects the atmosphere, Venus's oceans gradually started to evaporate. Water vapor is also a gas, and as more water droplets entered the atmosphere, a runaway greenhouse effect was created, which heated the planet even more and further accelerated the loss of water. Eventually, due to the intense heat, all of Venus's water dissociated. Among the hydrogen and oxygen atoms, hydrogen, which is quite light, escaped into space, while oxygen reacted with the surface materials, or it was stripped away by the solar wind. This process gave Venus a thick carbon dioxide-rich atmosphere. The story of Venus is truly heartbreaking. In 2019, when NASA's Parker Solar Probe was studying the Sun, it also provided an indirect piece of evidence related to Venus. This suggests that Venus still had a magnetic field. The probe detected some remnants that indicated the presence of Venus's ancient magnetic field. This raises the possibility that in the past, the environment of this planet was just like Earth's. This possibility that Venus was once habitable like our Earth. This data is important for our understanding of planetary evolution and the necessary conditions for life. If there were oceans in Venus's early history, then the question arises, could there have been life there? And if there was, what happened to that life after the planet became uninhabitable? To explore these questions, future missions will study Venus's atmosphere, surface, and geology in detail. By examining its surface, composition, and geological features, scientists hope that they can get a more complete picture of Venus's history. Future exploration. Despite its extreme conditions, Venus remains a top target for future exploration. NASA and other space agencies are planning a new generation of missions to unlock its secrets. One of the most exciting upcoming missions is NASA's Veritas, which stands for Venus Emissivity, Radio Science, INSA, Topography, and Spectroscopy mission, and it is set to launch in the late 2020s. Veritas will go into orbit around Venus and use cutting-edge radar and infrared mapping techniques to create detailed maps of the planet's surface. These maps will help scientists understand the geological history of Venus. This includes volcanic and tectonic activity, and scientists will look for signs of active processes on Venus such as volcanism and tectonics. The second planned mission is NASA's Da Vinci Plus, which stands for Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging Plus mission. This is also scheduled to launch in the late 2020s. Da Vinci Plus will send a descent probe into Venus's atmosphere, which will measure its composition and structure in unprecedented detail. This probe will also analyze noble gases and trace elements, which will provide us with insights into Venus's atmospheric evolution and the process by which it reached its current state. Da Vinci Plus will also capture high-resolution images of its atmosphere. Apart from NASA's missions, the European Space Agency is also planning its own mission to Venus called Envision. It will use advanced radar and infrared instruments to study Venus's atmosphere and surface, complementing the data collected by Veritas and Da Vinci Plus. All these missions together will provide a comprehensive view of Venus, which will help scientists understand its mysteries and its evolution. Recently, phosphine was discovered on Venus, which surprised everyone. Phosphine is a gas that is primarily produced on Earth through biological processes. Because of this, some scientists speculate that there might still be life somewhere in the clouds of Venus. But this discovery is still controversial, and we need more studies to confirm the presence of phosphine and to understand its origin. Scientists also have high hopes for India's Shukriyan, which will be launched to study the atmosphere of Venus. It is possible that this could give us some clues about life on Venus. In conclusion, while Venus seems like an inhospitable world, its history is perhaps filled with oceans, volcanic activity, and even the potential for life. By studying Venus, we can understand how the processes that shape planetary environments actually work. What conditions make a planet habitable or uninhabitable? What are the possibilities of life in our solar system and beyond? Looking towards the future, Venus is a key target that will help us understand our place in the universe. But when we look up at the sky, it gives us new hope with its brightness. It gives us a reason. To keep exploring the mysteries of this universe, it makes us who we are, always curious and always trying to understand this universe. Friends, what do you think about this topic? Please let us know in the comment section. If you like this video, be sure to like it and share it with your friends. For more videos like this, make sure to subscribe to the channel and turn on bell notifications so that you don't miss more deep dives into space exploration and scientific discovery. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.